Hello, my name is Todd Rothman, and I want to welcome you back to Organic Chemistry 1. In this video, we're going to learn about bonding. We're going to understand the different types of bonds that can occur, and we're going to also understand why bonding takes place in the first place. Okay, so why does it occur? And so let's get started. There are two sections, introduction and types of bonds. So the first thing I want to talk about is a general introduction about chemical bonds. Now, the question is, why does a chemical bond occur? And the very broad answer to this question, is that chemical bonds occur because of a reduction in energy from the system. Now, remember I had mentioned in the introduction video that really everything about what we're going to learn in organic chemistry is just really comes down to just things going from a higher energy state to a lower energy state. So that's really what organic chemistry is all about. You just want to bring things down into a lower energy state. So when a bond occurs, we actually allow the system, the both atoms that are making that bond, because you need two atoms to make a bond, it'll reduce the energy of both atoms, making it more stable. Okay, that's the driving force of a bond. Now, so again, the net result is a stabilization. Now, sometimes people say, well, the reason why you bond is to fulfill the octet rule, or another way to put it, not just say octet, but the outermost shell, the valence shell, is completely filled. The rule of having a closed shell. Closed shell means that the outermost shell that has electrons in it is going to be completely filled. Okay, now I don't mean the outermost shell that has no electrons, right? Because that can go to infinity. What we're talking about is wherever the electrons are that's furthest from the nucleus, if it is completely filled, then it's more stable. Okay, and this has to do with some quantum characteristics that we're not going to get too far into, neither here or in this course. You would learn about that much later on, but we'll get a general idea right now. So basically, the noble gases, if you recall, if we look at our periodic table, the noble gases are the ones that have 8 electrons in its outer shell. So that is the maximum number of electrons before you move to the next shell, right? So the next layer around that nucleus. Now, so everyone wants to become a noble gas because of how stable they are. What that means is that every single shell going up to the outer shell has complete filled electrons in it. And somehow there's a stabilizing characteristic to that. Again, without getting into a lot of really detailed stuff here in terms of quantum mechanics, it's going to be hard to go through the full explanation. And to be quite honest, if you dig far enough, we don't know the full explanation. So we kind of say, oh, it's an octet rule. I'm going to give you an analogy that you could use because we don't need to know the full explanation, but something that might help us to kind of make sense out of this in some way. Because here's what I know. I know that by putting electrons in the outer shell and filling it up completely, that represents stability. So all atoms want a filled outer shell. But I don't quite understand why that's the case. So what I think about is, consider, for example, a fan. Imagine if you have a fan, and that is my little diagram, a cartoon of a fan here. And imagine this fan has 4 blades, okay? Think of it as orbitals. So there are 8 electrons, 2 per blade. And now, when a fan spins around, if you think about what has to happen here is that each blade has to push air. Now, again, this is just an analogy, right? So just keep that in mind. So as the fan blade spins around, it pushes the air away and creates less friction, less resistance for the fan blade behind it. And so when this fan blade spins forward over here, then this one in the back is going to have less resistance because the air is pushed open, and as long as it's a nice distance away from it, it'll fall right through that area with less resistance. So notice how the fan blades are working together to help reduce the amount of strain as it spins around in space. Now, what happens if I was to take one of these blades out? Now, this fan blade here, when it spins over here on the left, the one below has a larger gap, so the air starts to fill back in there might be more resistance because now it has to break through the air. It's not able to go through. It's not close enough in proximity to go through and take advantage of the fan blade in front of it. This is what I think about. When I think about electrons being completely filled in the outer shell, somehow they all interact with each other to make it more stable, to make it less resistance, less some sort of energy reduction. Okay? Now, but when you start removing fan blades and you create distance, just like in this analogy here, now it's going to become a little bit harder for those fans to move around in space, right? Because they're going to have to break air. They're not going to be able to take advantage of their neighbor blade. And so, again, the analogy applies with two blades. So, again, if you look at this situation here, again, just think of it in more general terms. Fan blades help the neighbor blades spin through, break through that air, go into a circle, and it creates less resistance. And if you start removing them and you don't create proportions around, if you don't create the changes geometry, then you're going to have an issue. The fan's going to spin in a very awkward way because it's going to have more resistance. It's not going to be as fluid. Think of that for electrons. When you have electrons in the outer shell completely filled, somehow it works together, these electrons that are completely filled, in order to make it easier, less energetically, more energetically stable than if you start removing electrons from it. So partially filled, no good. When it's completely filled, it's a noble gas. It's very stable. Okay, that's it. If you don't get this analogy, no problem. Move on. Just remember a filled outer shell. Having a complete closed electron circuit or closed shell is what's required here. And it reduces the energy of the whole system. Okay, so that's the reasoning for chemical bonding. Now we're going to learn about the types of chemical bonds. So let's go into that. So the type of chemical bonds that you have are ionic and covalent. So ionic bond and covalent bond have some characteristics that are common amongst the two of them. So for example, all bonds, no matter what type of bond, occurs with electrons. So electrons is the glue that brings atoms together. It is what creates a bond, electrons. Okay, so the nuclei come closer because the electrons between those two nuclei are going to interact, and that's what makes a bond. Okay, no matter what the bond type it is. Now, all bonds occur through valence electrons. So the outermost electrons is what we use in order to make bonds. So again, you could see the importance of valence. Valence electrons, you could think of organic chemistry as a valence chemistry. It's all about what's happening with the valence electrons of atoms. Okay, so that's what we're going to see here no matter what the bond type is. And finally, bonding, as I mentioned above, is a stabilizing characteristic. When you make a bond, you're stabilizing the atoms because you're bringing them closer to a filled outer shell. Okay, the question is, how do you do that? And there are two ways: ionic and covalent bonds, and we're going to talk about those now. All right, but those are the common features of bonds. All bonds, no matter what the type of bond is, has that in common. All right, let's talk about ionic bond. Now, an ionic bond occurs when you have a metal and a non-metal. So recall from my periodic table that I showed you, on the left side is the metals, with the exception of hydrogen, right? I hope I made that clear before. These are metals. Okay, this is a non-metal, hydrogen. It's not a metal. Okay, it happens to be on the left side of the periodic table, but it's the only one. It's not a metal. So lithium, beryllium, sodium, magnesium, potassium, calcium, those are all metals. Now, these are our non-metals, including hydrogen. Okay, so non-metals. And what we do is when we have an atom on the left and atom on the right side of the periodic table come together, that is what makes up an ionic bond. Now, what does that mean in terms of, let me move this. What does that mean in terms of the reasoning for this? Why would this take place? Well, let's take a look at these concepts right here. Why metals and nonmetals? Well, the first thing is ionization energy. Now, what that is that's the amount of energy required to remove an electron. So what an ionic bond is where two atoms start